Hi my friends, today we model this part with this features, faces, surfaces with the name belt wheel support. The drawing is here, not very special. I forgot to place a center here because this is symmetrical. As you can see, with dimensions, we'll use them during the modeling. The source is this, coming from Timoteo Carrera Soto. I changed some dimensions and we respect as we can this number one model as well. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182, as you can see here. We start by creating this base plate with dimensions square 220, 145, holes of 25, radius of half of 75, and 20, 30, diameter of 60, radius 5, radius 5. New standard millimeters IPT, sketch XY plane, and we draw a rectangle with dimensions 220, tab 20. It must be placed with its center to the center point. Finish sketch, extrude, symmetrical 220. Okay. New sketch on this face. We draw a circle with a diameter of 60, placed at a distance from the center point of 145 divided by 2, then another dimension with the same value. Finish sketch, extrude 10 millimeters, fillet of 5 on both edges, hole this face, this center, diameter of 25 through. Okay. Then on this face we F7 we create a circle with this center and this diameter. Why? Because we want to extrude this corner. The other direction through. Okay, Now, since we have some features here, we can apply circular pattern for this, and extrusion about the axis Y. Not 6 but 4 instances, as you can see. This is the base plate. We continue by creating this post with fillets here. Dimensions are, as you can see, diameter of 55, distance of 180, and 2 arcs, 1, 2. You'll see that we don't need this 2 radii. Only this is important, and also this distance of 145, which is the distance between the centers of the 2 holes. This point will be important. You can see the construction of lines, like this one for instance, by looking back to the Timotheus drawing, original drawing. We use this plane, F7, we project this line, we verify is it 145, yes it is, but as a driven dimension. Then I create an axis from this point, which is the center point, at 180. Then to the left by 55 divided by 2, and down. Then I apply the dimension of 60 between these two, 60, and I draw an arc to here, and I wait to see this constraint. What means this? This means that this point is on the same line with this, same horizontal with this point. You don't see any dimension here. Then I draw a line from this point to this end. I make it construction line. Then I draw another arc from this point to this point. I place this center point on this line. I put the same point on the same vertical with this end point, and finally I place this point in the center of this line. Now we have a fully constrained sketch without dimensions for these two arcs. Let's verify. This is 75, I accept. This is half of 65, I also accept. These three are driven dimensions, but we use the geometrical construction here to create this combination of arcs. I make this center line and I apply revolve. Okay. Next is this revolving contour. Will start with the external contour, then with the internal one, but I create both contours at the same time, and I'll use sharing sketch. There are a lot of dimensions here. I let you take a look at them and watch my sketch. We use the same plane for the new sketch, XY, F7. I project this line. I make it construction line. Then I draw a line with a length of 83. This is a center line. I place this endpoint at a distance of 46, and I place it collinear with the other. Good. Let me move these dimensions to have room for other lines in the new sketch. Line from this point up somewhere here. I keep pressed the left button to create an arc. I keep pressed again the left button to create another arc. Then I find the tangency. I finish this line. I keep pressed the left button up, keep pressed again, and I go somewhere here. Let's place this contour at their dimensions. These two arcs are equal. These two arcs are equal. Dimensions are 5 for both on the right and 8 on the left. We have a dimension from this center line to up of the arc with the diameter of 85. This angle is interesting. It is 42 divided by 2. The other arc has its dimension, which is 140. This point is on the same vertical with this point. Let me see if I can move this to the left. Yes, I can. Same vertical between this endpoint, which is fixed now, and this point. Good. I move this a little up. This endpoint is still on the same vertical, and I create an arc with a center. Center is here, start is somewhere here, and it goes, as you can see, the radius is 35. I place this point on this line, then I create another arc with the same center, starting from here and ending somewhere. This must be 115, the radius. 115. And I eliminate this constraint because this point must be on the same vertical with this. But firstly, I make this tangent. Now I move this for a small distance and I apply this vertical. Good. The diameter for this point is 125. Then I draw a small line and I continue with another one. And now I apply this diameter of 102 and parallel for these two lines. The distance here is 10. Very good. One dimension needed. I'm trying to see what is that dimension. Yes, this diameter is 50. 50. Now we have a fully constrained sketch. Good. I add another line between this point and this end point, and now after I make a little order here, to see better what is here, I want you to see that we have the external contour, which is this one, and the internal contour, which is this one. I make construction these three entities, and now if I apply revolve, we'll have the external volume. Let's create this revolve. Okay, now that sketch used for the external, I make share, a share sketch. Double click on it, on this one. Yes, you see these are identical, absolutely identical. If you change something to one of them, you change also to the other. Double click here, then I make this normal lines, finish sketch, revolve. Now I have two selections. One is this and one is this. I select this one to be cutting a volume. The axis is the same. Okay. I hide this sketch and it is hidden also this. Did you get this interesting combination of sketches? Now we take a look here. This is an internal cut. You see this one. Not a big deal. Dimensions are 80, 35 and 30. We use the same famous plane, F7, and line 30 to the right sloped and closing line. I make this center line and I apply the two diameters. This is 1, 80, and this is another one, 35. Finish sketch. You see was fully constrained. You see this point here where you wait for a while and you see fully constrained. Three ways to find out if it is fully constrained. Then revolve, cut. Okay. The last thing is this radius 5 fillet. I select this 5 and I suppose this is all. Let's see. High properties, physical, update, copy, close, drawing, double click, and the value. The difference is very non-significant, but to respect our style of work, I keep the last one. Okay, let's apply material, which is still carbon, then the color, general color, which is red, and some faces to be machined. This is good, this is good. I keep pressed the left button, and this is good to be still polished. Now we have the part. That's all for today. Thanks for watching. Bye bye.